lucky enough to travel all around the world, which can make the Earth feel pretty small. In 2 hours, you're in another country, and by tomorrow, you're on the other side of the world. But our solar system is massive. We have 4 small planets and 4 giants. And guess what? Earth is one of the small ones. So today, I've enlisted the help of 9 of my closest friends to find out how big or small Earth actually is. The plan is to show the size of the planets in relation to each other to find out how big or small they actually are. While my friends are out grabbing the materials to make the planets, I need to crunch some numbers, and it's not really my specialty, so I got my friend Mark to help me out. How you going, Mark?
Hey, Nate, how are you?
Good. Now, you're a particle physicist, so for me, I mean, everybody at home, what exactly is that?
You don't know either, do you?
No, not at all.
Yeah, so a particle physicist studies the smallest things in the universe, like smaller than atoms, to the universe itself, and everything in between, which includes solar systems.
Sweet, Mark, you're the perfect person for the job. Now, what I want to do today is try to fit all those planets in this field right here to find out the comparison in sizes. How will we actually do that?
So what we need to do is actually scale down the planets to a size that we can see. So we need to shrink them all down, keeping them relatively the same size to each other. And so they'll end up being a very small percentage of their true size.
So it's kind of like my house here on the map.
Exactly. So your house, the street, the suburb, we need to scale it all down so that we can see it on the map.
Oh, that's great, but how do we actually do that?
Okay, so we need to take the measurements of your house, the street, the suburb, and divide them all by a common number.
Okay, for example, my house is 50 metres long.
Yeah, so on the map, that's about 5 millimetres, so we've divided it by 10,000. So 50 metres divided by 10,000 is 5 millimetres.
Great, and my street's 5,000 metres, so that would be maybe over the top and around the back. 500 millimetres?
Yeah, right, 500 millimetres. So that's a scale of 1 to 10,000, okay? So 1 millimetre on the map equals 10,000 millimetres in real life.
Oh man, that's just my house. How do you actually scale down the solar system?
Well, I've crunched the numbers, but I'll talk you through it, starting with Earth.
Now, is Earth actually big in the solar system?
It's actually pretty small in comparison, and we're going to make Earth a 1 metre wide circle.
Well, it's pretty small.
All right, let's roll out Earth.
Let's do it. Okay, so Mark, our Earth now is 1 metre in diameter. So what's our scale?
Well, the Earth is 12,756 kilometres in diameter. So our scale here is 1 to 12,756,000.
Wait a second, let me get this straight. So if I walk from one end of the Earth straight through the middle and out the other side, we can fit 12,756,000 of these?
Yep.
And that's a small planet. That's freaky. So, buddy, next to Earth, what do you think the next planet is?
I think it's Venus.
And how big do you think Venus is?
About 1 metre.
Yeah, great. About the same size as Earth.
Perfect. Good job, mate. Now, do you know which one's closest to the sun?
I think it's Mercury.
And Mercury, it's a bit smaller than Earth, so make sure this one's a little smaller than a metre as well.
It's good when we get people to do the job for us. How you going, little man? So we're after Earth. Which planet do you think this is?
This is Mars.
Mars is smaller than Earth, so make sure you bunch it up nice and tight.
Coming up later in the show, we measure out the rest of the planets.
Hi, my name's Josh Richards. I'm a physicist and engineer that's worked in stand-up comedy in all sorts of different areas. Now, I'm 31 years old, which some of you might think is really old, but it's certainly not as old as these two. Now, here we have the first meteorite ever discovered in New South Wales, coming in at about 800 million years old. But this guy, this one is even older again. This is formed from a stromatolite where cyanobacteria grow on top of each other and slowly fossilise over time. And we believe this is about 900 million years old.
Today on Get Clever, Jackie and I are doing some stargazing.
Except it's not going very well. Shouldn't we do this at night time?
Jackie, I'm scared of the dark. All we have to do is just move around a bit. I'll orbit this way and you orbit that away. Get it? A bit of solar system here.
The The Sun is considered an average star, and yet you could fit 1 million Earths inside of it. For years, it was believed that Earth was the only planet with liquid water. But recently, NASA has provided its strongest evidence yet that Mars intermittently has water running across its surface. One of the moons of Jupiter, Europa, is also suspected to have a saltwater ocean underneath its thick ice. Space junk is any human-made object still orbiting the Earth that has no useful purpose. Scientists suspect there's about 500,000 pieces of space junk in orbit today, and they include everything from pieces of old rockets to satellites to even spanners dropped in the construction of the International Space Station. The sunsets on Mars are blue. There are more stars in the sky than there are grains of sand on all the beaches of Earth. At least 1 billion trillion.
I love neon. It's so much fun. I also love parties. So I'm thinking about combining neon with some of my favourite science experiments to make some really cool party decorations. This place would look so much better with some glowing oobleck. Now that's a weird word for a weird substance, but I'm going to get back to that one later. First though, I need to make my neon water. And for that, you'll need a highlighter pen, a large jar, and some warm water. Also an adult to help you get into your highlighter pen, unless you're strong like me. Okay, now I've got the felt open, I'm just going to put some gloves on so I don't end up with pink ink all over my hands. Take the felt out like that and drop it into the warm water. Now you're going to leave that to soak overnight. And here's one I made yesterday. And look how cool that is. It's so pink. Okay, now it's oobleck time. Remember that weird substance that I was talking about earlier? Well, it's kind of like the naughty kid at school who doesn't play by the science rules. To make oobleck, you're going to need some water and an empty cup, some corn flour and a measuring cup. So you need 2 parts corn flour to 1 part water. Mix the corn flour and the water together until the corn flour dissolves. It might get a little bit messy. Oh, it's like slime. And then when you press it, it turns into a solid and then back into slime again. So cool. But let's get into the science. It's neither a liquid nor a solid. It's something in between called a suspension. But today's all about neon. So I'm going to get rid of this and make a much bigger vat of glowing oobleck. Okay, same as before, 2 parts corn flour to 1 part neon water. So now my oobleck's really pretty and pink, but I'm going to make it even cooler by making it glow in the dark. And to do that, I need to take my gloves off first. So this is a UV globe, and it gives out invisible light that we can't see. We can only see visible light. But the neon water contains something called phosphors, and phosphors absorb that invisible light and then give out beautiful glowing visible light that we can see, just like this. Hope it gets glowing reviews from my friends. Now it's time for a montage. Neon party!
I've been aiming for the stars today, and boy, I think I've just found the best one by far. No, not that kind of star, a celebrity star. And she's sitting just over there. Okay, Nathan, play it cool, play it cool. Just wow her with your awesome star facts. Deep breath. Go for it. Hi, Taylor. My name's Nathan. No, that doesn't sound good. Taylor, hey, Nathan here. What? No. I wonder if my breast stinks. It's good. Taylor Swift, Nathan Morgan, nice to meet you. Playing it cool, eh? Yeah, me too. I'm just down here stargazing and you're the closest star to me. Well, okay, cool. Do you know what the closest star to Earth is? I take that as a no. Well, it's actually the sun. I know, I was pretty surprised when I first found out as well. You just look up in the sky and you just think it's a big light keeping us warm.
Nathan, what are you doing? It's me.
Oh my gosh, I actually thought you were Taylor Swift.
Thanks.
That would have made my day. Anyway, moving on. Today on Get Clever, we're measuring out the planets to a scale of 1 to 12,756,000. I've set the girls the task of laying out one of the gas giants. Let's see if they can guess which one it is. This planet scales down to 11 metres, but ran out of paper at 5.5, so I got the girls to grab some other materials just so we could actually get to the 11 metres. Good work, girls. Keep the hustle up. And that's the end of the tape measure at 8 metres. So, girls, we're going to need another 3 metres over here, okay? Go, girls, you can do it! I'm just, measuring stuff. They're doing the hard work. Whoa, this is massive. What planet do you think it is?
It's massive, so I think it's Jupiter.
Yeah, and so Jupiter is actually the first of the gas giant planets, and its diameter is more than 11 times that of Earth.
Okay, we've got 1, 2, 3, 4, 5. What planet's number 6?
Saturn is number 6.
So smart.
Yeah, so Saturn's the one with all the big pretty rings, and we're going to measure out 9.5 metres.
Kira, could you hold this for me? Stand over there. And all the way back. Oh, yeah, that's the end of it there. We've got 8 metres here, so we need an extra 1.5 metres.
And here we go.
Okay, so that's 8 metres, an extra 1.5.
1.5.
Perfect, 1 mark. Okay, so, yeah. Okay.
Nathan, we've got a problem.
What's the problem?
There's no more materials to make the solar system.
Do you hear that, Mark? We've ran out of materials up. So what other planets do we have to do?
Well, we've still got Saturn, Uranus, and Neptune. They're all a bit smaller than Jupiter, but hey, at least we managed to make Jupiter.
Yeah, and then we don't have Pluto anymore because it's not a planet. Let's use everything we've got and make Jupiter really round to really show off how big it is.
Let's do it.
I love this. It really gives you a picture of how vast the solar system actually is. I can't imagine having all those numbers in my head, but this gives me a really good picture. But I've got 2 more questions for you. What about the sun?
Well, the sun is actually so huge that we couldn't fit it on the same scale as these planets.
So it wouldn't even fit in this field.
No, the sun is over 100 times the diameter of the Earth.
I mean, it looks big in the sky, but not that big.
No, that just shows you how far away it must be to look that size in the sky.
Mark, I've got to say you're the smartest guy I've ever met, but do you believe in aliens?
Well, look, there are billions of stars in our galaxy and billions of galaxies in the universe, and we're seeing that a lot of those stars have planets around them, so there must be millions and billions and trillions of planets, so I think it's probably likely there's something out there. Yes.
Okay, that's a whole other episode. Mark, guys, thank you so much. I've learned so much today, but I think I might wrap myself for Jupiter now.
I'm Harleen. I'm Guinevere. I'm Mia. I'm Jonathan. Our project is called Here to Help, and they're gloves for blind people because guide dogs can be $30,000 to $50,000. So they're pretty expensive, and these, if they were made in factories, they would only be $50 to $100. And so they're a cheaper and much better option to guide dogs. There are sensors. There's the main board on this glove, the buzzer motor, and the battery holder. And so these gloves work so if it's a 30 centimeters or a meter away from a wall or object, it'll shake or shiver. So for instance, when this glove, when it'll know when it's near a wall, so they'll kind of shake or shiver and they won't annoy the people around them. Firstly, we saw the prices of guide dogs. They're 30,000 to 50,000, so as I said, they're very, very expensive. And these would only be 30 to 50, so they're a lot cheaper. Well, to plan it only took 1 or 2 weeks, and to build it took about 3 months because we weren't really sure what we were going to do. And unlike the last 2 weeks, we just got everything, so it was really hard. What we would do if we made it again, we would have added another Arduino board and actually put some more lights and sounds on it. So then it would work better and actually have like more sensoring and more like notification. So we thought to do a noise, but then it would like everybody around them would stop and look and say, oh, what's that? But then if it's just a simple going like that, then you'll be notified, but nobody else around you will.
I found the hardest part to be the whole gloves pretty much.
All of it was pretty hard, but I guess the hardest was probably thinking of the idea. Because we were all fighting at the start and trying to figure out what to do. Our original idea was actually for blind people playing sport, like catching balls, and the sensors would be on the inside. But then our teacher reminded us that that would be a lot harder to do, so we changed it to walls. Guinevere's going to walk towards an object to show how the gloves work. What happens is all together the main board, the buzzer and the battery holder, they all together know that an object is in front of them. I coded the main board to tell when the buzzing, it would start buzzing and shaking to know if something's in front of them.
We've been doing some pretty amazing star spotting today, and you should see what I just saw. Oh, wait, it's just a plane.
This is Josh Richards reporting from Uranus, or as some people like to call it, Uranus. A truly unique planet. The first thing that you notice about Uranus is that while most planets spin like this, Uranus is on a tilt, so it spins a bit more like this. So, as it makes its way around the universe on a tilt and backwards, we have to ask, how did Uranus get like this? What we suspect is that it crashed into a planet about the size of the Earth that put it on the tilt and made it go crazy around the solar system. Looking out, I can see several of Uranus's moons, of which there are 27, and they're all kinds of wonderful names like Belinda and Portia and Ariel. Some of them are clumped so close together, it's hard to understand how they don't crash into each other. And they're all kinds of wonderful shapes and colours. Like Saturn, Uranus also has rings. Some of them are dark grey, others are red, but all of them are incredible. We're a really long way out from the sun here as well. To give you an idea, it takes 8 minutes for light to go from the sun to Earth. But for light to get from the sun all the way out here to Uranus, it takes 2 hours and 40 minutes. It took me literally years to get out here. And it was very lonely. There was no one on the spaceship for me to play I Spy with all the way here. Not that there was much to see on the way anyway. There's a small core in the centre of the planet and the rest is made up of icy materials. There's a cloudy top and then below that a layer of methane. And it's this gas that gives Uranus its spectacular blue and green colour. To the weather, and it's going to be another extremely cold and windy day with temperatures getting down to minus 200 degrees. I think, because my instruments are frozen, which means I can't really use them, but I can still do this really cool Uranus dance. Back to you in the studio, everyone.
We've had a great day stargazing today.
We have seen a total of no stars.
Not one.
Except for the sun, that's technically a star.
Still very disappointing though.
Yeah, well, how about I cheer you up with some awesome facts about the universe?
Yeah, that's really going to cheer me up.
Okay, check this out. Did you know there's 200 to 400 billion stars in the galaxy?
Sure did. Did you know that most stars are between 1 to 10 billion years old?
Knew that. Bet you didn't know that it takes millions of years for the light of the stars to travel to Earth. So when you're looking at the stars, you're literally looking back in time.